Good morning, children. Welcome back to our class. Just now we discussed the defect of myopia and how to do the correction, means by using which type of lens we can do the correction. For the myopia problem, we have to use concave lens, by concave lens. And now we'll discuss about another one is hypermetropia. So there are three types of defects: myopia, hypermetropia and presbyopia. So myopia we have completed. Now coming to hypermetropia. Hypermetropia means the people, they can see far objects but they cannot see near objects. Actually, for a healthy person at a distance of 2.5, he can see an object clearly, but for this hypermetropia people, they cannot see at a distance of 2.5 centimeters. So beyond that, they can see an object. Due to this reason, hypermetropia is known as farsightedness. For example, 1 minute. For example, this person, actually the least distance of distinct vision is 25 centimeters. And from this he can see an object. A healthy person can see, but for coming to the hypermetropia, the people at a distance of 25 centimeters, they cannot see image clearly. So from this, beyond that, up to which point or which distance he can see, after that, at what distance the person can see an image of object clearly, that point becomes the near point for that person, hypermetropia person, or defect of that person. The person, they don't have he can see all objects which are very far to him, but the person cannot see the near object from 25 centimeters. So from that, beyond that, up to from that, at what point the person can see, that point becomes the near point for that hypermetropia people. Okay, from this he can see an object up to infinity, but before near point, the person cannot see any object. So at what point from the least distance of distinct vision, or from the from the infinity to at what point the person can see, that point becomes the near point. And this near point, it is represented with the letter H. Once again, we'll read the definition. Hypermetropia: a person with hypermetropia can see distant objects clearly but cannot see object at near distances, because the minimum focal length of the eye lens, actually the minimum focal length for the maximum eye lens adjusts its maximum and minimum. So minimum means 2.27. For this hypermetropia people, the minimum focal length of focal eye is greater than 2.27. It is greater than 2.27 centimeters. Due to that, the image is forming beyond the retina. Due to this, maximum to focal length greater than 2.27 centimeters, the image is forming beyond the retina. If the image is formed on the retina, then only we can see. Either before or beyond, we cannot see any image. In such cases, the rays coming from a nearby object after the refraction at eye lens forms an image beyond the retina. What is near point? The point of minimum distance. The point of minimum distance at which the eye lens can form an image on the retina is called near point, and it is known as, it is represented by the letter H. Okay, now coming to the ray diagrams. This is the eye lens. Here this is the least distance of distinct vision. From this distance the person cannot see an object, so far he can see. So from the far to up to which distance, minimum distance he can see, that point becomes the least distance of, for a healthy person this is the least distance of distinct vision. For this hypermetropia people, depends on the person, this distance is the least distance of distinct vision, and due to that the minimum focal length is actually it is 2.27, but it is more than 2.27. Due to that it forms beyond the retina. So how to do this correction? For such people, if you bring the object in between near point, either at the near point or in between, or not in between, if you bring an object at the point H, H means near point, or beyond H, he can see the image clearly. He can see the image clearly. So how to do this correction? By using which type of lens we can get they can see the object. Myopia people, we discussed the biconcave lens, and for this hypermetropia people they can use convex lens, biconvex lens. If they use biconvex lens, how they can see an object? How they can see an object? Ray diagrams are very, very important. See, this is the eye. I will take another pen. So this is the eye lens. If they use biconvex lens, then this is the optic center. Suppose if we take that is the optic center, this H is the, actually this is the least distance of distinct vision for a healthy person, and for the hypermetropia this is the least distance of distinct vision. This is the least distance of distinct vision. If an object brings at H or beyond H, then the person can see. So if they use biconvex lens, then from H it is near only, so the rays are diverging. So when the diverging rays forms on the on this convex lens, then the rays are diverging. So these diverging rays, they seems to be appear at one point, so they will meet. So here we get the image. The hypermetropia people, when they use the convex lens, the object lies for them, by using a convex lens, the image of an object lies either the near point, it lies on the in between H and least point, means this is the near point and least distance of distinct vision. Then for the eye lens, the eye lens receives this object, as an this image an object. The eye lens receives this image as it is an object, and it from this object the rays falling on the eye lens, divergent rays are falling on the eye lens and will converge on the retina. So due to that they can see the image clearly. This is about hypermetropia, and these ray diagrams are very important. Thank you.